The Great Pyramid is aligned to true north with an error of only 3 arc minutes, the width of a human hair at 10 feet. That tiny, microscopic mistake isn't random. It points to a specific moment in the sky, a date the builders should not have been able to calculate 4,500 years ago. Look at the stars. Every culture throughout history has done the same. But 4,500 years ago, a civilization in a sun-drenched desert built something that mirrored the sky with extraordinary precision. The Great Pyramid of Giza. We all know its scale and its stone. But what if its most interesting secret lies not just in how it was built, but in how it was aligned, and in a slow celestial motion called precession? The Great Pyramid is one of the most accurately oriented ancient structures ever built. Its sides are aligned to the cardinal directions with an error of only about 3 to 4 arc minutes from true north, roughly 5/100ths of a degree. That is an astonishing level of precision for a monument built around 4,500 years ago. And that tiny error isn't random, it's a clue. To understand why, we need to talk about Earth's wobble. Imagine a spinning top. As it spins, its axis slowly traces a small circle. Earth does the same. This is the precession of the equinoxes, a roughly 26,000-year cycle in which the direction of Earth's rotational axis slowly shifts in space. Today, our pole star is Polaris. Around the time the Great Pyramid was built, the pole star was Thuban, in the constellation Draco. As the celestial pole moves, the whole sky appears to rotate very slowly over thousands of years. The positions of stars relative to the horizon change by tiny amounts from century to century. Any attempt to align a monument to true north using stars will therefore lock that monument to a specific era in this long cycle. Modern measurements show that the Great Pyramid's orientation is consistent with a construction date in the middle of the 3rd millennium BC, around the reign of Khufu, if the builders used circumpolar stars near Thuban to find north. Different astronomical alignment models give slightly different dates, but they all cluster around the conventional archaeological chronology. But the 3 to 4 arc-minute error, that tiny deviation from true north, is more than just a historical timestamp. It's a testament to the genius of their methodology. How exactly did the builders, lacking modern telescopes or GPS, achieve such astonishing accuracy? The prevailing scientific theory points towards a technique known as sighting 2 circumpolar stars, specifically tracking the rising and setting of 2 stars near the pole, like Mizar and Kochab, at the same time. By observing these 2 stars as they passed vertically one above the other, a moment called transit, the Egyptians could bisect the angle between them to establish a perfect north-south line. This method, reliant purely on observation and simple geometry, minimizes errors caused by the atmosphere and refines the alignment far beyond using a single star. Think of it as ancient trigonometry done with the naked eye. The tiny 3 arc-minute error we measure today is not evidence of a flaw. It's the signature of this precise stellar observation method from 4,500 years ago. It implies the Egyptians had standardized tools like the Bay and Merchet and a rigorous multi-generational process of astronomical record-keeping. This astonishing precision, achieving less than 1/10 of a degree of error on a structure weighing 6 million tons, is why the pyramid is often called a colossal geodetic marker. Its cardinal alignment is perhaps the greatest practical achievement in applied astronomy in the ancient world. But alignment to north is only the beginning. The Giza Plateau also appears to encode the sun's path. At the summer solstice, when viewed from near the Great Sphinx, the setting sun drops in the gap between the Great Pyramid of Khufu and the Pyramid of Khafre. This striking effect may relate to the ancient Egyptian hieroglyph Akhet, the sun setting between 2 peaks. Whether or not it was designed exactly this way, it shows how carefully the builders thought about the horizon, the sun, and the landscape. Inside the Great Pyramid, narrow channels, often called air shafts, rise from the king's and queen's chambers. They are too narrow to be practical ventilation ducts, and their exact purpose is still debated. Some researchers have proposed that they were aimed at specific stars that were important in Egyptian religion at the time of construction. In this interpretation, the southern shaft of the king's chamber roughly targets stars in Orion's belt, associated with the god Osiris, while the northern shaft points close to Thuban, the then pole star region used for orientation. Other shafts may roughly align with Sirius and stars in Ursa Minor. The alignments are not perfect laser sights, and they are not universally accepted, but they do fit reasonably well with the sky around the mid-3rd millennium BC. This raises a fascinating possibility. At minimum, the builders clearly understood the sky well enough to align a 6-million-ton monument to north with only a tiny error, to place the pyramids in meaningful relationship with the sun's path, and possibly to point internal features towards specific stars that mattered in their religious worldview. That is already an extraordinary achievement, without invoking lost civilizations or alien technology. You may have heard claims that the Great Pyramid encodes advanced mathematical and astronomical constants, that its dimensions contain the value of pi, or even the length of the precessional cycle, about 25,772 years. These ideas usually rely on a modern unit called the pyramid inch, and on choosing particular measurements and combinations of edges and diagonals. The numerical coincidences can be interesting, but there is no solid evidence that the ancient Egyptians deliberately encoded the full precession period in this way, or that they used the pyramid inch as a real unit. Most Egyptologists view these schemes as modern numerology, rather than hard evidence of hidden scientific codes. What we can say with confidence is this: the Great Pyramid's precision is not accidental. Its cardinal alignment, to within a few arc minutes, strongly supports a carefully planned astronomical method for finding north. The likely association of the internal shafts with key stars fits the religious and symbolic logic of the time. And the solar sightlines on the plateau underline how closely Egyptian monument building was tied to the motions of the heavens. Whether the builders recognized precession as a full 26,000-year cycle is uncertain. Some scholars argue they may have noticed that the sky slowly changed over many generations. Others are more cautious, pointing out that we lack explicit Egyptian texts describing precession. But even without solving that debate, the Great Pyramid remains a monument to careful observation. The builders used the stars as their clock, their compass, and their framework for placing stone on stone. The truth of the Great Pyramid's alignment is in many ways more inspiring than any fantasy. These were not primitive people. They were master engineers and keen sky watchers, able to translate patient observation and practical geometry into a structure that has stayed locked to the Earth's axis for 4.5 millennia. The pyramid's sides face the 4 cardinal directions, but its true reference frame is the moving sky above it. It is one of the oldest and grandest astronomical instruments on Earth. If you were astounded by the scientific precision hidden in the Great Pyramid, hit the like button and subscribe. Thanks for watching. Veil Origins. Impossible Truths.